This video covers condensation polymerization, which is the type of polymerization you need for level 3. I'll do a quick recap on the level 2 addition polymerization, but then I'll go into this condensation polymerization. What we're going to cover in level 3 are the formation of polyesters, the formation of polyamides, and the formation of polypeptides. I'll then go into explaining the hydrolysis of the polyesters, where we have to break the ester links, and the hydrolysis of polyamides, which is breaking these amide links. These questions here you'll be able to do after the video, hopefully all going well. If you get stuck, send me a message. I'm more than happy to help you. So a recap from level 2. Level 2 involved addition polymerization. For this type of polymerization, you need your monomers to have a double bond. What happens is that double bond breaks and enables it to join onto a neighboring monomer, whose double bond also breaks, enabling it to join onto an adjacent. And so you form this very long chain of what were ethene monomers. Notice the double bonds are no longer here, they're all single bonds. The name is polyethene, which is the name of the monomer with the prefix poly in front. Here's another example from level 2 where I've got chloroethanes. One of the hydrogens has been replaced with a chlorine atom. Doesn't matter which hydrogen you choose, but you'll notice that if you look carefully, it's only every second carbon that has got a chlorine atom. And this is what we would call polychloroethene, or polyvinyl chloride was its common name, or PVC, which we also know it by in today. I'll just do one further one that's common at level 2. This monomer might look a bit unusual. It's got a benzene ring instead of having the 2 hydrogens off this carbon. So we call this styrene. And when it polymerizes, you'll find that every second carbon has this benzene group. Don't worry about whether it's up or down, makes no difference, as long as you have it on every second carbon. And likewise, if you have it on the first carbon, then as long as it's then on the third and the fifth, again, it's the same polymer. And that's your polystyrene, which is used for takeaway coffee cups and packaging around appliances that you buy. Now into the level 3 concepts. So the first type of polymer we'll look at is the formation of polyamides. Now you'll see in the second part of the name, amide, that sort of gives it away. They form through the amide links. And so we've got highlighted here is an amide link, the carbonyl carbon next to adjacent to a hot nitrogen atom. Okay, so that's the amide link, and we'll look at the formation of those. And then the second one we'll look at is the formation of polyesters, and these have an ester link. And you've got here highlighted what an ester link looks like, a carbonyl carbon onto an oxygen. So in order to form a polyester, what you'll need is a diol and a dicarboxylic acid. A diol is an alcohol which has got 2 OH groups, and this A represents carbons. It could be just CH2, could be multiple CH2s, but what this A is not important because it's not part of the formation of where they join the monomers in order to form the polymer chain. So this here is a dicarboxylic acid. It's got the carboxylic acid at both terminal ends. So it's got it here at the beginning and it's got it here at the end. And I've got some more examples that I'll bring up, but what this B is not important. So yeah, you'll see that it can change. It could be a benzene ring, could be a CH2 or multiple CH2s. So polyesters form through condensation. This is where the H from the alcohol and the OH from the carboxylic acid gets removed, and then that will enable the link to form. And it occurs at both ends of the monomers, which enables it to form this length of polymer chain. So it does link directly to how an ester formed. So just a quick recap, ignore that page number, it's not relevant to this iPad. So this is your carboxylic acid, this is your alcohol. So when ester formation occurred, again it was the OH from the carboxylic acid and the H coming off the alcohol in order for the ester link to form. And it's no different for polyesters, other than it doesn't occur just at one place. It'll occur at both ends of the monomers. And you'll see that upon removal of the water molecule, you get the ester link, and then it would form another ester link here to another dicarboxylic acid. You'll typically only get asked to show one repeat unit, and this is one repeat. It's got both the carboxylic acid and then the alcohol forming the one repeat unit. Notice here the CH2, which was represented with either an A or B in the previous diagram, and here you've got two CH2 groups. This is the same illustration, just another example where you've got your carboxylic acid. This time, instead of having an A or a B here, you've got a benzene ring. And I've still got two carbon CH2 groups there, but the process is the same. OH comes off the carboxylic acid and the H comes off the alcohol, and that forms your ester link. And this is another graphic showing you the exact same process. So these are your two monomers, an alcohol and a carboxylic acid, dicarboxylic acid I should add, and yeah, I think I've repeated that enough for you to understand. Don't worry about these names, certainly don't need to know those whatsoever. Now there is another way to make a polyester, and that is not through having two different monomers, which is what this process that I've illustrated here involves. You had two different monomers. It is possible to form it with just one single type of monomer, but the monomer would have a carboxylic acid and a hydroxyl group, which is what we call an alcohol group when you're not naming it as a functional group. A hydroxyl group is, if you like, the alternative name if you were naming it as a branch. Just to illustrate this, so we'll just zoom in here. What you've got is the alcohol at one end, again it doesn't matter if it's on the left side or the right, and a carboxylic acid at the alternative end, and it will undergo the ester link with itself. So each of the repeat units is just one monomer. There you go, it's lost its hydrogen off the alcohol, and then it's lost its OH in order for it to then link to another one of that particular monomer. And so that's a repeat, and that's a repeat. Okay, so those are the ester links, and that would be a polyester. This is not common. Most of your exam questions will involve the two different monomers, where you've got a dicarboxylic acid and a alcohol, a diol, I should say. Alrighty, moving on to polyamides. So as the name gives away, when these link together, you will get a amide link. So the difference is, well, there's two ways to make it. Number one, you could use a dicarboxylic acid, and this time a diamine as opposed to the diol. And because your amine's got the NH2 group, that's where it's going to link. There is a second way to make polyamides, and that is through a diacid chloride and a diamine. Again, a diacid chloride just means it's got two acid chlorides, and they'll be at the terminal ends. This is just to remind you the basics of forming an amide. So again, it's OH group off the carboxylic acid and an H off the amine, and that there is your amide link. Okay, and it will repeat itself, so the next dicarboxylic acid would link to this end here, and you'd have, like, if I color coded it, it would be that next green unit, and then it would alternate to the amine. So again, another graphic shows you the same thing. What you've got here is the dicarboxylic acid and the diamine, and it's just losing that water molecule to form the amide link. Now this is nylon, which is what stockings are made out of, nylon fishing line, and we'll do an experiment in class where we actually get to make this using a dicarboxylic acid and a diamine. So we'll do that when we're back in class. So that's an illustration showing you multiple units where you've got the A and the B representing either CH2s or benzenes, and you can see where the water molecule is leaving. Finally, polypeptides. So this relates back to the formation of a dipeptide. The process is identical. OH group of the carboxylic acid of your amino acid and an H of the amine forming your amide link, and then it would go further and repeat itself with another amine at both ends, and you'd get a long continuous chain, which we call a polypeptide. So I think here again it just illustrates the formation of the initial peptide link, but it would occur again here. So the next amino acid would come in to this place here where I'm circling on the right hand side, and the amine group would react with this carboxylic acid. Hydrolysis. So to do the polyamide hydrolysis, what you're first going to do is bind your amide links, so your carbonyl carbons next to the nitrogen, identify those, and that's where it splits. And as we've done hydrolysis earlier, what we'll add on is a water molecule. The hydro is the giveaway that you've got water, lysis meaning split. So the OH group will go onto your carboxylic acid and regenerate your carboxylic acid group, and an H will go onto the amine end, and that will regenerate your hydrogen. Sometimes you're asked to identify the monomers in an exam question. What you're wanting to do is look for your ester links or your amide links, as that is where it will split. So this one would split here between the carbonyl carbon and the oxygen, and likewise here. And you'll always get a hydrogen go on to a single oxygen, and an OH group going onto the carbonyl carbon. So that's showing you the split. Okay, so that's where it's splitting at those ester links, and that then you put the H onto the single O's, so you get your diol back, and you'll get a carboxylic acid back. If you were to have acidic or alkali conditions, it applies the same as when we were doing acidic or alkali hydrolysis of just the ester or just the amide. I should add, this is the hydrolysis of a polyester, and just going back, that was the hydrolysis of an amide. But it is identical to when we were doing the hydrolysis reactions earlier. So that brings us to the end of the explanation, and I did want to keep this video short, but I can see it's already near 14 minutes. So if you work through this iPad and get stuck at all, then by all means message me, but hopefully my color-coded answers illustrate it well enough and you can see how it works. But do feel free to get in touch. Okay, best of luck guys.